This video is for chapter 1.3 notes. It's a short section on the idea of called simple random sampling. Now that we know why we conduct statistics, how we then have to decide between a design experiment versus an observational study, we then have to get this information from a group of people, from the population, and how we do that is through what we call a process called sampling. And in statistics, what we want to do is we want to conduct random samples. And so we have this definition of random sampling. And this idea of random, we're going to talk about in class, but it doesn't mean usually the word that you think it means. Random has a very precise definition in statistics, and it's usually different than what you think. So when we're looking at some example of this idea, random sampling is the process of using chance to select individuals from a population to be included in the sample. And so this idea of random sampling, right, using chance to select individuals from a population to be included in the sample is this idea of random. Something to note: for the results of a survey to be reliable, the characteristics of the individuals in the sample must be representative. Very important word here, representative of the characteristics of the individuals of the population. And we'll talk more about that. The key to obtaining a sample representative is to let chance or randomness play a role in dictating which individuals or people are put into the sample. There's something called convenient sampling that's not good. That's where you just pick anybody without thought. Some people think that's random, but it's not random. And so you want to be mindful of this idea of convenience. The results of, if you just do it without some process, then the results would be meaningless. This leads us to this section here, where we talk a very specific process called simple random samples. And the idea is just that everyone has the same chance of being chosen from a sample. And so what is a simple random sample? A sample of size n from a population of a bigger population, right? A sample is going to come from a bigger population, so we use small n and big N. For a sample of small n, big N is for population, is attained through, and so how are we going to do that? Comes back to, see this better than my writing, is obtained through simple random sampling if every possible sample of size n has an equally likely chance of occurring. This sample is called a simple random sample. Simple random sampling, right here. Simple random sampling is obtained through simple random sampling if every possible sample of size n has an equally likely chance of occurring. This is called a simple random sample. And I'll just do an example of that, but we'll talk again more about this in class. Simple random sample. And so in this case here, let's say we have 30 clients, and the firm wants to select 5 of these 30 clients. How would you do that? In a simple random way, what you do is you can put these 30 names in a hat and just pull them out. You can, what we're going to do in this class is I have 30 choices, and then we use what we call we use random numbers. So I have 30 companies. I want to select, there's 30, and on this problem, what do we want to do? Let me just repeat. We want to select 5 of these, 5 of them, and so give me a sample size of 5. And so this would be a simple random process. Here would be the 5 companies we choose, just letting some random number generator do that for us, and we could continue to do that. And then we end up with different samples. That's an example of a simple random sample, and we'll have to talk about more complex ways of doing that, which would on the next section. But obtaining a simple random sample, I just showed you an example. Put all the names in a hat and pick them out like a old school way of doing it would also be a simple random sample. And that's it for 1.3.